Hello there, welcome to this video where we continue taking a look at Bertrand Russell's Principles of Mathematics. In the last video, I got up to the end of section 59. So in this video, we're going to start off quite naturally with section 60. So we're in chapter 5, titled Denoting. So I'm hopefully going to make it to the end of this chapter in this video. So there's been I've been thinking about what I want to do with this, whether to make this into a more comprehensive series of videos, what I want to do after I've made this video, because the original plan was to just go through chapter 6 on classes. That became going through chapters 4, 5 and 6. And now I'm considering actually just going through the whole of part 1 of Principles of Mathematics. So in that case, after this video, I may go on to I may stick with the previous plan, which was to go through to the end of chapter 6, and then go back to chapter 1 and start from the beginning, do chapters 1, 2, 3. And then 7, 8, 9, and 10. Or actually, after this video, just go back to chapter 1. I've not decided yet. So, however, this is probably going to be the last video that I make for maybe a week or so. I'm expecting that I might be a little bit busy over the coming weeks. So, the uploading frenzy might have to come to an end for a short while. So there's just a couple of things that I just want to talk about before moving on, before starting with section 60. Something that I did actually mean to comment on in the previous video, which was, so if we look at section 58-ish, I'm just trying to find the place where it occurs. Around section 58. Yeah, section 58. So, Russell uses the word objects in section 58, and he's put a little note about it. And he says, I shall use the word object in a wider sense than term to cover both singular and plural, and also cases of ambiguity, such as a man. The fact that a word can be framed with a wider meaning than term raises grave logical problems. Okay, so the word objects is a very useful word to use. I understand it as being used in quite an informal sense, because if we turn back to chapter 4, so section 47, Russell kind of defines the word term as whatever may be an object of thought, or may occur in any true or false proposition, or can be counted as one I call a term. And then he goes on to say, this then is the widest word in the philosophical vocabulary. So it seems strange then that we have a word now, object, which seems to have an even wider meaning than the widest word in the philosophical vocabulary. And all I can attribute to this is that the word object is being used in a kind of informal sense, and it can be used in a bit of a lazy sense as well. And I do this from time to time. If there is something that is difficult to classify, a word that is difficult to classify, and it's pending further analysis to determine which category it kind of belongs to, or what it denotes, or just something that's difficult to classify at a given moment, but where you really want to kind of keep things going, keep the flow going, you can just refer to it as an object, I guess. I do this all the time in these videos, and sometimes I'm doing it deliberately because I don't know specifically how to classify a word or a term or whatever. So I just use that generic word object just to keep things going, really. And Russell kind of does this as well. So it is a bit can be a bit lazy sometimes, but actually it can be kind of necessary, because it might be practically impossible to actually determine the exact nature of one of these objects that you're referring to. So I just wanted to kind of clarify that. The last video got a bit rambly towards the end. Section 59 is it's a difficult section, really. I was bringing in certain parts of section 60 and section 61 to try to prop me up a little bit as I was going through that section, because from my perspective, section 59 on its own, it doesn't really fully explain the concepts that we were trying to get our heads around in that section. Section 59 itself is not, in my opinion, necessarily sufficient to get a full kind of understanding of the concept, if it is even possible to get a full understanding of the concepts. So I was starting to kind of jump ahead of myself a little bit and bringing in bits of section 60 and section 61. So it did get a bit of a mess. Hopefully I'm going to be able to clarify some of the details of section 59. So I'm going to go through section 60 and 61 now. Hopefully what I say now will kind of clarify some of the difficulties that we encounter in section 59. When it comes to section 61, I'm not going to go through absolutely everything. What Russell does there's some subsections, alpha, beta, and gamma, in section 61, where he gives several. How many examples does he give? He gives like 30 or so, 32 examples of the denoting concepts all, every, any, are, and some in different contexts, being used in different situations. It can get a bit repetitive, and not only that, I don't think it's actually worth me going through them. It's when it comes to these, it's really, you've got to read through them yourself and form your own understanding, really. I do have some comments that I want to make on them, but I'm not necessarily going to go through. In fact, I'm not going to go through all of the specific examples that he gives. I'm not going to be going through them. Okay, so let's make a start then with section 60. So let me find the right place. Where are we? There we go, section 60. So as usual, I will try to remember. I didn't do this very well in the last video. I'll try to change the screen when I the problem that I've got is that the end of what's at the end of a page in my book here is not necessarily what is what's at the end of the page in the digital version that I'm using. So it's not just when I get to the end of a page here that I just go and change the screen. They're actually not the same necessarily. So sometimes I forget. I just carry on reading and I don't change the screen. So it would help if you've got your own copy of Principles of Mathematics to hand. Okay, so section 60 then. When a class concept A is given, it must be held that the various terms belonging to the class are also given. That is to say, any term being proposed, it can be decided whether or not it belongs to the class. Okay, so in other words, we can make a definite decision. Given a particular class, its membership is completely determined. Okay, so it's not, we can't find terms that where it's undecided whether that term is in the class or not. We might not be able to practically decide. From a practical perspective, we may not be able to determine whether that term is a member of the class or not, but the view that Russell is taking is that the term is, whether we know it or not, it is in the class or it is not in the class. So there are no terms that are both in a class and not in a class, if that were possible, or any other weird combination that you can possibly think of. Either a term is in the class and it's entirely in the class, or it's not in the class, and it's entirely out of the class. Okay, so there's no kind of fuzziness there. In this way, a collection of terms can be given otherwise than by enumeration. Okay, so in other words, we don't need to go through actually pointing to terms, so to speak, and saying that is in the class, that is a member of the class, this is a member of the class, and this is a member of the class. We can actually give a class concept, and that class concept is sufficient to determine the membership of a class. Okay. Again, terms are either in the class or not in the class, and having been given this class concept, the class is fully determined. We might not necessarily, from a practical standpoint, be able to determine the exact membership, but we can be assured, on Russell's view here, that the class is fully determinate. Okay, and there's no fuzziness about the concept. Whether a collection can be given otherwise than by enumeration or by a class concept is a question which, for the present, I leave undetermined. So this is the giving a collection by enumeration. This is the intensive definition, or by class concepts. Sorry, wrong way around. That's the extensive definition. So enumerating the terms, this is an extensive definition of the class. Given the class concept, that would be an intensive definition. So what he's saying here is that there might be other ways. These are the two ways that we've really considered, but there might be other ways that we can determine classes. But we're not really bothered about it. If there are, these are the only two ways that we currently need to consider. But the possibility of giving a collection by a class concept is highly important, since it enables us to deal with infinite collections, as we shall see in part 5. So enumeration limits us, at least on a practical level, to finite classes. Now, whether on a theoretical level we can still get away with extensive definitions of classes, that's maybe a different question. I think it does deal with that, actually, in I'm trying to think off the top of my head, chapter 6. But certainly from a practical perspective, there's no way that we can effectively point to an infinite number of terms to extensively define a class. So from a practical perspective, we need class concepts. They are very useful to us because it allows us to break that barrier and go on to beyond finite classes, and we can start dealing with infinite classes, or as he says here, infinite collections. For the present, I wish to examine the meaning of such phrases as all A's, every A, any A, an A, and some A. All A's to begin with denotes a numerical conjunction. It is definite as soon as A is given. The concept all A's is a perfectly definite single concept which denotes the terms of A taken all together. Okay, so A is a class concept. All A's is a denoting concept, and it denotes, so all of the terms which fall under this class concept are denoted by all A's collectively. Okay, so what we'll see is in chapter 6, this is effectively the meaning of a class. So it's where all of the terms that fall under this class concept are denoted by all A's as a collective, as a kind of a single unit. There's still a bit of ambiguity though about whether we consider it as one or many, because there are many terms, and it's kind of the manyness that's being denoted, but it's a single class. Okay, so there is a little bit of haziness here, and I think I said in the last video, a class it's almost like a limit between many and one. Okay, the terms are they're combined in a particular way, such that they're not quite one, but they're not quite many. Okay, so that there is a certain amount of separateness about them that prevents them from being considered one. But there's also enough unity to prevent them from being considered many. A very unusual idea. This is these are the kinds of ideas that Russell is trying to explain. And as I've said previously, we're trying to understand Russell's ideas as best we can, even if it seems to conflict with our own personal prejudices about this or that idea or whatever. We're trying to understand Russell. So even when he makes some very unusual distinctions or says things that seem quite strange to us, we're still trying to make the effort to understand things from his perspective. So the concept all A's is a perfectly definite single concept which denotes the terms of A taken all together. The terms so taken have a number, which is not necessarily finite, which may be regarded, if we choose, as a property of the class concept, since it is determinate for any given class concept. So this is, if you've read Frege's Foundations of Arithmetic, there's an air of Frege about it. In fact, let me grab the book from my bookshelf. So it's quite far in. It's a while since I've read it, but where is it? I'm sure I've underlined it somewhere. Okay, so obtaining the concept of number is right. So yeah, Frege. So I've opened it up at section 62 here. It's probably not the best section, but he's talking about the number which belongs to the concept F is the same as that which belongs to the concept G. Okay. So numbers, for Frege, numbers belong to concepts. So Russell is saying that we can consider the number as a property of the concept, but what he will go on to say, he disagrees with Frege. From my understanding, Russell considers number as a property of classes. He doesn't identify classes with concepts, with the class concept or something like that. The class to Russell is a definite object in its own right, okay? And its number is a property of the class, not... We can consider it as a property of the concept, I guess, in an indirect way. But it's, strictly speaking, in Russell's view, a property of the class. So yeah, and number, we're not necessarily talking about finite numbers. When Russell's talking about number, even though we haven't got around to defining it yet, that's for part 2, chapter 11, for example. He doesn't make a distinction. He can't make a distinction at this stage between finite number and infinite number anyway. Number is just number. Because there isn't any way for us at this moment in time to really make a distinction between finite and infinite. Although he will, obviously, from an intuitive perspective, we understand what's well enough what the distinction is between finite and infinite. What I'm talking about here, we're not in a position to make a logical distinction between the two concepts. We're able to still psychologically distinguish between finite and infinite. And actually, once we get on section 61, there's some examples that are given where we restrict ourselves to a finite number of terms. Well, these are just the examples that Russell gives here. They're kind of they're just psychologically helpful. Okay, they're not logically necessary, if that makes any sense. Okay, so continuing on then. Every A, on the contrary, though it still denotes all the A's, so that's important, it still denotes all the A's, denotes them in a different way, i.e. severally instead of collectively. So there's kind of a distributivity here. with every A. So all A's it denotes all of the A's collectively, so to speak. Every A denotes each of the A's in a kind of distributive sense. Okay, so if we fixate, if we've got all A's, if we fixate on one of the A's, we can be sure that all A's does not denote that particular term that we fixate on. Okay, whereas with every A, if we fixate on a particular term, we can be sure that that term is denoted, but also all of the other terms, all of the other A's, all of the other terms which fall under that class concept are also denoted. Okay. So then we move on to any A. So any A denotes only one A, but it is wholly irrelevant which it denotes, and what is said will be equally true whichever it may be. Okay, so this is distinct from the previous case. So with every A, remember, all of the terms are denoted. So we fixate on a term, we can be sure that that term is denoted by every A. But as well as that term being denoted, all of the others are denoted. In this case, what he's saying is that one of the terms is denoted. If we kind of fixate on a term, one of the A's, so we're talking about any A now. If we fixate on one of the terms, we can be sure that any A does not denote that particular one. Okay, so any A denotes a term, but it's not necessarily this term or that term or the other term. It's a strange. Again, it's quite strange and difficult to kind of twist your mind around to understand this. I can't say that I've fully convinced myself that I'm happy with my understanding of it. But also, whatever assertion we can make about any A will be true about each of the terms. Okay, but again, the difference here between every A and any A is that with every A, we can be sure that every term is denoted. With any A, one of the terms is denoted, but it's irrelevant which one. Okay, if we fixate on one, we can be sure that the one that we fixate on is not the one that is denoted. It's a certain combination of all of the terms. But again, any assertion that's made about any A can be made about any of the individual A's. Right, so moreover, any A denotes any A denotes only one A, but it is wholly irrelevant which it denotes, and what is said will be equally true whichever it may be. Moreover, any A denotes a variable A. That is, whatever particular A we may fasten upon, it is certain that any A does not denote that one, and yet of that one, any proposition is true, which is true of any A. There are some comments in section 75 and sections 87 which might help in kind of understanding a little bit better this any A. An A denotes a variable disjunction. Oh, so also something that I wanted to say. I'll wait until I get onto section 61 for that. An A denotes a variable disjunction. That is to say, a proposition which holds of an A may be false concerning each particular A, so that it is not reducible to a disjunction of propositions. So it might be worthwhile thinking about the examples that we were given in section 59 with Miss Smith and her her lovers. So example 4 was, which corresponded to this an A idea. If it was one of Miss Smith's suitors, it must have been Brown or Jones. So I'm going to just adapt it a little bit, because it seems if it was one of Miss Smith's suitors, let's just add a little bit to that. If it was one of Miss Smith's suitors which you met, it must have been Brown or Jones. It just, to me, it makes a little bit more sense like that. So it may be true that it must have been Brown or Jones which you met, but it's not. It doesn't necessarily mean that it must have been Brown or it must have been Jones. It could have been Brown and it could have been Jones, but it's not necessarily true that it must have been Brown or that it must have been Jones. So in other words, something that is asserted about an A is not forced to be true. You can't necessarily make the same assertion about any one of the individual terms. So this is quite a strange thing, that surely if you make an assertion about an A, surely there should be at least one of the terms that you can make this assertion about. Actually, that's not the case here. Okay, so again, thinking about this example, if it must have been the case that you met Brown or Jones, but it's not necessarily. You can't say, well, it must have been Brown or it must have been Jones. Neither of these are necessarily true. They may be, but they're not forced to be. And this is, the distinction that's being made about an A. Okay, so whereabouts are we? For example, a point lies between any point and any other point, but it would not be true of any one particular point that it lay between any point and any other point, since there would be many pairs of points between which it did not lie. Okay, and then finally, this brings us to sum A, the constant disjunction. This denotes just one term of the class A, but the term it denotes may be any term of the class. Thus, some moment does not follow any moment would mean that there was a first moment in time, while a moment precedes any moment means the exact opposite, namely that every moment has predecessors. So again, it might be worth thinking back to section 59 and the fifth example that we were given. Miss Smith will marry Brown or Jones. Okay, so what's being said here, so if we can be certain that Miss Smith is going to marry one of Brown or Jones, then it's true that Miss Smith will marry Brown or Miss Smith will marry Jones. So in other words, this assertion that's made about Brown or Jones, that Miss Smith will marry Brown or Jones, can be split in this case into kind of a propositional disjunction, because what we end up with is not identical. The proposition that we end up with is not identical with Miss Smith will marry Brown or Jones. If we split this into Miss Smith will marry Brown or Miss Smith will marry Jones, but it's true that Miss Smith will marry one of Brown or Jones. So Miss Smith will marry Brown may be true, or must be true, or and the other one not true, or vice versa. So one of these terms, what we assert about sum A must be assertable about one of the terms. It's just it could be any of the terms. Okay, so when we assert Miss Smith will marry Brown or Jones, this will be true. This assertion will be true of one of the terms, one of Brown or Jones. It's just that it could be either Brown or it could be Jones. Right? Again, it's kind of difficult at first to wrap your head around these ideas, but if you think about them long enough, you do start to come round to seeing things from Russell's perspective, even if you don't fully agree with it. Okay, so on to section 61 then. In the case of a class A which has a finite number of terms, say A1, A2, A3 up to AN, we can illustrate these various notions as follows. So that's what we've got here on the screen. These are quite useful in my opinion. It's worth spending a bit of time with these. So all A's denotes A1 and A2 and and AN. Okay, so the and here, so bear in mind we've got two words. We've got and we've got or, but we've got five different concepts. So we've got two words but five concepts. So we're straining the use of the words. He does acknowledge this, that the use of these words is really being strained here. So all A's denotes this particular combination, A1 and A2 and AN, and is being used here in a very particular way to denote a very particular type of combination. It's called numerical conjunction. And so he talks about this in section 59, numerical conjunction of terms. Okay. The second case, every A denotes A1 and denotes A2 and denotes AN. So here is seems to be really emphasizing that each of the terms are being denoted individually and separately. Right, so whereas before when we had all A's denotes A1 and A2 and so here the terms are kind of they're kind of stuck together, and they're being denoted in a certain sense, in a very loose sense. They're kind of stuck together in a particular sense. They're glued together with this word and what is denoted is the collection of these A's. Every A's denotes A1 and denotes A2. So here the separateness is being emphasized, I guess. Any A denotes A1 or A2 or or AN, where or has the meaning that it is irrelevant which one we take. Oh, by the way, every A that's the propositional conjunction. Again, section 59 talks about propositional conjunction, because the what is asserted about every A, there's an equivalent proposition that we can form, which is the conjunction of the so if we make an assertion about every A, we can make the same assertion about A1, the same assertion about A2, the same assertion about A3, and we can form the conjunction of all of these individual propositions. The assertion of A1, assertion of A2, are applied to A1 and applied to A2. And this is equivalent to every A, the assertion made with regards to every A. So it's the propositional conjunction. Any A denotes A1 or A2 or AN, where or has the meaning that it is irrelevant which we take. And this is called the variable conjunction. So again, here, an assertion made about any A, we can be sure that the assertion is also true about any of the individual terms. The difference between this and every is that whereas every A denotes each of the terms individually and separately, any A denotes one of the terms, but it's just irrelevant which one it is. Okay. An A denotes A1 or A2 or up to AN. So notice that it's exactly the same form here that we're using. So what I was saying in the last video, you can't just rely on the bare form to tell you what is being denoted necessarily. Where or has the meaning that no one in particular must be taken. Just as in all A's, we must not take any one in particular. So this is called the variable disjunction, as opposed to the variable conjunction. And in this case, again, any assertion that's made about an A is not necessarily true about any of the assertable about any of the individual terms. Some A denotes A1 or denotes A2 or or denotes an. So again, we've got the separateness there, where it is not irrelevant which is taken, but on the contrary, some one particular A must be taken. So there's what is asserted of some A can be asserted about some one of the terms. It's just it could be any of the terms. It could be any of the terms which it is asserted of. So spend some time thinking about those, and good luck trying to figure it out. It's still difficult for me personally to really. Sometimes I feel that I've got it. Sometimes I think, yeah, I'm happy with my understanding of these distinctions, and then sometimes it feels like it slips away from me. The distinctions are just so fine sometimes. It seems that you've got to be in the right mindset, and it's very easy to slip out of that mindset. And if you slip out of it just a little bit, then you seem to you can't seem to hit the mark. As the nature and properties of the various ways of combining terms are of vital importance to the principles of mathematics, it may be well to illustrate their properties by the following important examples. So these are the sections alpha, beta, and gamma, which I'm not going to go through. Although I am going to say, it's interesting what he says here. As the nature and properties of the various ways of combining terms are of vital importance to the principles of mathematics. So I distinguish personally between the principles of mathematics and mathematics. So, for example, my undergraduate was in mathematics, so I'm familiar with how these words all, every, any, and some are used in kind of genuine mathematical contexts. And I've got to say, never have I thought about these words in the way that Russell is talking about them here. In many ways, I kind of take it for granted. When I see these words, I take it for granted. I kind of intuitively know what they mean. And I've never really thought about them in a lot of detail, but what I can say is I definitely don't think about them in the way that Russell talks about them here. And I don't think Russell is saying that this is how these words should be understood when we're doing mathematics. This is how these words should be understood when he's talking about the principles of mathematics. So the principles of mathematics, kind of the foundational principles of mathematics, which is different to mathematics. Mathematicians, generally speaking, are not terribly interested in the philosophical foundations of mathematics. So these words are how Russell is talking about them here and using them is, in his opinion, relevant and necessary to the principles of mathematics. There's no suggestion here that as any mathematician should modify his or her way of thinking and accept these ways of understanding those particular words. Okay, I think the way that these words are understood and used in mathematics is perfectly, there's no problems there. There's no need to change anything. But Russell is not talking about mathematics, he's talking about the principles of mathematics. Okay, so these finer distinctions may be necessary on that kind of philosophical level. So after the examples of beta, he says, in this case, actual mathematics have compelled the distinction between the variable and the constant disjunction. In fact, let me change the page. But in other cases where mathematics have not obtained sway, the distinction has been neglected, and the mathematicians, as was natural, have not investigated the logical nature of the disjunctive notions which they employed. So, I don't know, maybe it is the case that mathematicians do kind of subconsciously or on some level understand these words in the way that Russell is suggesting here. I just think it's not a conscious thing. It's much more intuitive. Okay, so skipping right to the end of section 61 then, we get the above examples show that although it may often happen that there is a mutual implication which has not always been stated, of corresponding propositions concerning some and a, or concerning any and every, yet in other cases there is no such mutual implication. Thus the 5 notions discussed in the present chapter are genuinely distinct, and to confound them may lead to perfectly definite fallacies. So what he's saying here is that in some cases these pairs of words, some and a, and any and every, on the other hand, they might appear to be kind of interchangeable, or to be capable of being used interchangeably. But that just happens to be the case in some sets of circumstances. In other sets of circumstances, there really is, in his opinion, a genuine distinction which needs to be drawn between some and a on the one hand and any and every on the other hand. And failing to make these distinctions, as he says, may lead to perfectly definite fallacies. So it does appear in some cases that some of these words can be used interchangeably without really bringing about any appreciable change in the meaning of what is being said. But that's not forced to always be the case. Just because that's the case sometimes doesn't mean that it's always the case. Okay, so on to section 62 then. It appears from the above discussion that whether there are different ways of denoting or not, the objects denoted by all men, every man, etc. are certainly distinct. It seems therefore legitimate to say that the whole difference lies in the objects, and that denoting itself is the same in all cases. Okay, so remember what we were trying to do. We were trying to figure out whether there's just a single object that is being denoted, but it's being denoted in different ways, or whether there's different objects that are being denoted in the same way, or whether there's different objects that are each being denoted in different ways, or some variation on this. The conclusion that he's come to is that there appears to be appears to certainly be the case that there are different objects that are denoted in each case. But we can't really determine whether there's just one way of denoting or whether there's a different way of denoting in each case. And actually, it doesn't actually make any difference to us at this stage. Knowing that there's different objects that are denoted is actually sufficient for us. So it's beside the point now. So for all intents and purposes, we may as well assume that there's just one way of denoting. There may be many ways, but actually it just doesn't make any difference to us. There are, however, many difficult problems connected with the subject, especially as regards the nature of the objects denoted. All men, which I shall identify with the class of men, seems to be an unambiguous object, although grammatically it is plural. But in the other cases, the question is not so simple. We may doubt whether an ambiguous object is unambiguously denoted, or a definite object ambiguously denoted. So I think what he's getting at here is that there may actually be different ways of denoting. Because in some cases we have something unambiguously denoted, and in other cases we've got something ambiguously denoted. So if it's the same way of denoting, is it possible for the same way of denoting to denote sometimes ambiguously and sometimes unambiguously? Actually, it doesn't really make any difference to us again. But he does go on to say, consider again the proposition, I met a man, which is actually going to change because the wording of this, understand that, again, the way that the way that we use words in everyday speech and in doing just mathematics is not necessarily the same way that Russell is instructing us to use words here. Or at least... I need to change the page again, don't I? Russell is giving very strict meanings to his words to make distinctions on a certain level. On the level of principles of mathematics, let's say. But when we go to everyday use of these words, they don't necessarily coincide. So he's not saying that everyday speech should change to his much more precise versions of these words, or much more precise meanings of these words. He's just pointing out really that there is a distinction. So we have to be careful, okay? Rather than using everyday speech when we're wanting to talk about the principles of mathematics, we're going to have to revert to this much more strict use of language. But once we go back to everyday life, just doing mathematics, whatever, then we can just revert back to what we normally do, okay? But what he's saying here is the proposition expressed by "I met some man." Consider again the proposition "I met a man." It is quite certain and is implied by this proposition that what I met was an unambiguous, perfectly definite man. In the technical language which is here adopted, the proposition is expressed by "I met some man." But the actual man whom I met forms no part of the proposition in question and is not specially denoted by some man. Remember, some man, it denotes a combination of terms, arguably, in a very loose sort of sense. It denotes a combination of terms. Thus, it is a definite man that is denoted. But it could be any man. Again, how the hell do you make sense of this? But you've got to try. I've got to try. Thus, the concrete event which happened is not asserted in the proposition. What is asserted is merely that some one of a class of concrete events took place. So I guess the concrete, in this case, the class of concrete events would be that I met this man, or I met that man, I met the other man, met, somebody else. It's one of these events that actually happened, that actually took place. It's just, it could have been any. The whole human race is involved in my assertion. If any man who ever existed or will exist had not existed or been going to exist, the purport of my proposition would have been different. Or to put the same point in more intentional language, if I substitute for man any of the other class concepts applicable to the individual whom I had the honour to meet, my proposition is changed, although the individual in question is just as much denoted as before. What this proves is that some man must not be regarded as actually denoting Smith and actually denoting Brown, and so on. The whole procession of human beings throughout the ages is always relevant to every proposition in which some man occurs. And what is denoted is essentially not each separate man, but a kind of combination of all men. Okay? Make of that what you will. This is more evident in the case of every, any, and a. There is then a definite something, different in each of the 5 cases, which must, in a sense, be an object. That word again. But is characterized as a set of terms combined in a certain way, which something is denoted by all men, every man, any man, a man, or some man. And it is with this very paradoxical object that propositions are concerned, in which the corresponding concept is used as denoting. So remember, it's just worth bearing in mind that in all of these cases, all men, every man, any man, a man, and some man, what is being denoted is some particular kind of combination of terms. Okay. Right. Also, there is a comment that I wanted to make. I meant to do this right at the beginning of the last video that I made. In section 31, which I'm not going to bring up on the screen, but denoting. There's a quote from section 31, right at the end of section 31. What is meant by denoting, as well as the different ways of denoting, must be accepted as primitive ideas in any symbolic logic. So in other words, we can't define denoting, and we can't define the ways of denoting. What denoting means, what the concept denoting means, and if there is one way of denoting, or if there are many ways of denoting, whatever, these must be accepted as primitive ideas, okay, indefinable in our system. Okay, on to section 63. So it remains to discuss the notion of the. So this was left out. So remember in an earlier section, he highlighted 6 words: all, every, any, are, some, and the. But he isolated the because it's got its own curious properties, particular properties. So it means to discuss the notion of the. This notion has been symbolically emphasized by Peano, with very great advantage to his calculus. But here it is to be discussed philosophically. So I think one of the reasons that Russell doesn't use a lot of symbolic language in this Principles of Mathematics is because, I mean, obviously he uses some, but it's not heavy symbolically. And I think the reason for that, or one of the potential reasons for that, I'm speculating here, is that once you start to introduce a symbolism, what can tend to happen is that things become, your focus is more on what kind of symbolic transformations can you make. So even if it's an informal symbolism, as long as it's systematic, it's got a logic to it, it's got rules to it. So, for example, in mathematics, obviously, mathematicians use a symbolic language. It's systematic, it's got rules, it's got a logic to it. But if we take this, how mathematicians will typically symbolize sets, for example, it's very rare for a mathematician to be concerned with the philosophical, the nature of a set. On a philosophical level, what is a set? What kind of an object is a set? What mathematicians are going to be typically interested in is what kind of symbolic transformations can I make in this language when it comes to sets, when I'm dealing with sets. So the attention kind of shifts when you've got a lot of symbolism involved. The symbolism can often become more about what can I do with the symbols? What kind of transformations can I make with the symbols? As opposed to analyzing the things that the symbols are being used to represent. Okay. Also, there are certain things, as we'll see when we come on to classes, sometimes it's necessary in a symbolism to have symbols to represent things that may not even on a philosophical level exist, such as the null class, right? So according to Russell, on a philosophical level, the null class, we'll see, doesn't exist. We've got a symbol to represent it, though. We need he doesn't argue that we are wrong with our symbolism to have a symbol to represent the null class. We actually kind of need it, and it makes perfect sense to have that symbol there. So null class, compare with empty set or something like that in set theory. And he says that the symbolism that's used in the the class calculus, for example, is, in his opinion, the best option. It seems the best practice to use it. It's just on a philosophical level, we draw different conclusions about how things work. So another distinction is in symbolism, we need to, for technical reasons, I guess, make a distinction between a class which has a single member and that single member, right? So these are not identified. Whereas on a philosophical level, Russell will argue that there's no real way that we can distinguish these two. So if we're just dealing with the symbolism, we draw different conclusions. Yes, these two things are different. The object and a class whose only member is that object are two different things. But on a philosophical level, the conclusions are potentially quite different that we draw. Whereas if we were using a symbolism, we may be distracted from the philosophical side of things and be asking, well, what does the symbolism tell us? What does the symbolism say about this, that, and the other? And we might draw different conclusions. So this is potentially one of the reasons why he doesn't make heavy use of symbolic notation. Now, it's not that there wasn't symbolic notation at the time. There was. Piano's symbolic had a symbolism for logic and classes and things like that. There were symbolic languages, but there was no kind of generally accepted symbolic language for a lot of these ideas. So another reason that Russell doesn't really use a symbolic language is because there wasn't necessarily a very very widely accepted or well developed symbolic language to express these ideas. There's all different reasons that we could postulate about why he doesn't use symbolism, but to me, an over-reliance on symbolism or heavy reliance on symbolism can be a distraction. And I'm not necessarily saying that that's wrong or that it's a bad thing. It's just that's how it is. So if you're wanting to analyze on the philosophical level, sometimes the symbolism can get in the way. Okay. Where was I? The use of identity and the theory of definition are dependent upon this notion, which has thus the very highest philosophical importance. The word "the" in the singular is correctly employed only in relation to a class concept of which there is only one instance. We speak of the king, the prime minister, and so on, understanding at the present time. And in such cases, there is a method of denoting one single definite term by means of a concept, which is not given to us by any of our other 5 words. It is owing to this notion that mathematics can give definitions of terms which are not concepts, a possibility which illustrates the difference between mathematical and philosophical definition. So terms which are not concept, things, right? So we can use concepts to point towards things, to gesture towards things, to denote things. So there is this curious relation that exists between certain concepts and certain things, the denoting that which is denoting and that which is denoted. Every term is the only instance of some class concept, and thus every term theoretically is capable of definition, provided we have not adopted a system in which the said term is one of our indefinables. It is a curious paradox, puzzling to the symbolic mind, that definitions theoretically are nothing but statements of symbolic abbreviations, irrelevant to the reasoning and inserted only for practical convenience, while yet in the development of a subject they always require a very large amount of thought and often embody some of the greatest achievements of analysis. So, on the symbolic level, definitions are superfluous. Arguably, we don't really need them on a theoretical level. Practically, they are important because they can, we can use them as a kind of abbreviation for very complex strings of symbols, and really, from a practical perspective, we do depend on them. But it's almost like a definition brings something. It gives it. It's almost like it gives it more existence. That sounds like a strange thing. I'm not speaking in a very precise sense here, but it's almost like when something is defined, it becomes more real, more actual in a certain sense, I guess. This fact seems to be explained by the theory of denoting. An object may be present to the mind without our knowing any concept of which the said object is the instance, and the discovery of such a concept is not a mere improvement in notation. So when we realize that this concept and this thing have this relation, have such and such a relation. This thing is denoted, is the one and only instance of this concept. That's quite enlightening to us. It's not just a symbolic convenience. There's actually something there it's not just, as it says, an improvement in notation. This is potentially something that improves our understanding and knowledge of the world around us, or whatever field of work that we're in. The reason why this appears to be the case is that as soon as the definition is found, it becomes wholly unnecessary to the reasoning to remember the actual objects defined, since only concepts are relevant to our deductions. In the moment of discovery, the definition is seen to be true, because the object to be defined was already in our thoughts. But as part of our reasoning, it is not true, but merely symbolic, since what the reasoning requires is not that it should deal with that object, but merely that it should deal with the object denoted by the definition. In most actual definitions of mathematics, what is defined is a class of entities, and the notion of the does not then explicitly appear. But even in this case, what is really defined is the class satisfying certain conditions. For a class, as we shall see in the next chapter, is always a term or conjunction of terms and never a concept. So in other words, we don't identify a class with class concepts. Although, if I remember rightly, we can kind of, under certain circumstances, we can identify a class with a class of equal class concepts. So there might be many different class concepts that all correspond to the same class, and we can potentially consider the class of all equal class concepts. So equal class concepts are those class concepts which all correspond to the same class. We'll talk about that in when we look at chapter 6, whether it's in the next video or another video. Thus, the notion of the is always relevant in definitions, and we may observe generally that the adequacy of concepts do deal with things. The adequacy of concepts to deal with things is wholly dependent upon the unambiguous denoting of a single term which this notion gives. Oh, I need to change, don't I? Section 64. The connection of denoting with the nature of identity is important and helps, I think, to solve some rather serious problems. The question whether identity is or is not a relation, and even whether there is such a concept at all, is not easy to answer. So why wouldn't identity be a relation? Well, a relation seems to be something that relates two terms. But identity seems to really relate, when it holds, it really holds between a term and itself. So it's hardly two terms. Now, obviously, for those familiar with mathematics, it's very common to regard we can take two. How can I explain? We can consider the same object as as two things, in a certain sense. This is kind of done in a lot of cases in mathematics, but again, we're on the philosophical level here, where it's not necessarily sensible to consider a single term as two potentially separate things. For it may be said, identity cannot be a relation, since where it is truly asserted, we have only one term, whereas two terms are required for a relation. And indeed, identity, an objector may urge, cannot be anything at all. Two terms plainly are not identical, and one term cannot be, for what is it identical with? Nevertheless, identity must be something. We might attempt to remove identity from terms to relations, and say that two terms are identical in some respect when they have a given relation to a given term. But then we shall have to hold either that there is strict identity between the two cases of the given relation, or that the two cases have identity in the sense of having a given relation to a given term. but the latter view leads to an endless process of the illegitimate kind. So the illegitimate kind is when we've got an infinite chain of if we go back to, where is it? Right, there's an endless I've just seen it. So section 55. There's an endless process. It talks about endless processes. Again, the notion of specific differences, it may be urged that if differences differ, their differences from each other must also differ, and thus be allowed into an endless process. So it's kind of an endless chain of relations, I guess, which there's an illegitimate kind if we're trying to analyze the meaning of something. Russell argues that if we're trying to analyze the meaning of something, if we're trying to come to an understanding of what something means, we can't have these infinite, endless processes. So an infinite chain of kind of relations would, if it pertains to our understanding, if it comes into our attempts to try to understand the meaning of something, then we can't have that. This is an infinite process of the illegitimate kind, because it's coming into our attempts to try to understand the meaning of something. If it comes in, if an endless infinite process comes in another way where we're not trying to analyze the meaning of something, then it may be legitimate. It may be admissible. Okay. So thus identity must be admitted, and the difficulty as to the two terms of a relation must be met by a sheer denial that two different terms are necessary. There must always be a reference and a relatum, but these need not be distinct. And where identity is affirmed, they are not so. Okay, so in other words, in the case of identity, we're going to accept identity as a relation. What we're going to do is we're going to say that when we have a relation, the reference and the relatum may be the same. They don't need to be distinct objects. But the question arises, why is it ever worthwhile to affirm identity? This question is answered by the theory of denoting. If we say Edward VII is the king, we assert an identity. The reason why this assertion is worth making is that in the one case, the actual term occurs, that's Edward VII, is the actual term in this case, while in the other, a denoting concept takes its place, the king. For purposes of discussion, I ignore the fact that Edward's form a class, and that 7th Edward's form a class having only one term. Edward VII is practically, though not formally, a proper name. Often two denoting concepts occur and the term itself is not mentioned, as in the proposition, the present Pope is the last survivor of his generation. So what Russell is saying is that identity is actually really important, because identity can be asserted between, it doesn't have to be two terms that we assert identity between. We can assert identity between a term and a denoting concept, or possibly even between two different denoting concepts. So if in the first case we've got a term and a denoting concept, if that denoting concept denotes that term, then we have an identity, and it's a non-trivial identity that we're asserting. So Edward VII is the king. So we're talking. This is 1903. So Edward VII, was it Edward VII? I don't know my kings. But let's say Edward VII is the king. I think it was Edward VII. I don't know. I don't know my the royal lineage well enough. Edward VII is the king. So the king. So we're talking about a particular moment in time where Edward VII presumably was the king. So the king, in that case, denotes Edward VII. So therefore, saying Edward VII is the king it's a non-trivial identity that we're asserting here. And if you read Russell's article on denoting, then this is not a trivial identity like asserting Edward VII is Edward VII, for example. It's a non-trivial identity that's being asserted here. But we can also have two denoting concepts. So the Pope is the last survivor of his generation. The present Pope is the last survivor of his generation. So provided that the present Pope, which denotes a particular term, and the last survivor of his generation denotes the same term, then again we've got an identity, but a non-trivial identity. Now, there are complications with this when it comes to if we've got what's called a description. If a description doesn't actually denote. So he uses in that article on denoting, he uses the example, the present King of France is bald. So the present King of France, there is no such thing. It doesn't denote any term. So there are complications around when we've got a description which doesn't, it's a denoting concept, but it doesn't denote anything. So we can have this. We can have a denoting concept that fails to denote. Okay? Or it fails to denote any term. There's difficulties around that. So when a term is given, the assertion of its identity with itself, though true, is perfectly futile. So it's trivial, right? To say Edward VII is Edward VII. Well, yeah, okay, fine. But also, I mean, but when we come to denoting, to descriptions and denoting concepts, to say, so Edward VII is Edward VII would be true, provided that we understand Edward VII as a proper name. Whereas if we take the present King of France, if we say the present King of France is the present King of France, this would be false. Again, it's one of those difficulties. If you read Principia Mathematica as well, I think it's chapter 14, section 14 in Principia Mathematica, there's a much more thorough treatment of descriptions in there. So, yeah, when a term is given, the assertion of its identity with itself, though true, is perfectly futile and is never made outside the logic books. But where denoting concepts are introduced, identity is at once seen to be significant. In this case, of course, there is involved, though not asserted, a relation of the denoting concepts to the term, or of the two denoting concepts to each other. But the is which occurs in such propositions does not itself state this further relation, but states pure identity. Okay, so then on to 65, and this is the last section of this chapter. So, yeah, to sum up, when a class concept preceded by one of the 6 words all, every, any, are, some, the occurs in a proposition, the proposition is, as a rule, not about the concept formed of the 2 words together, but about an object quite different from this. In general, not a concept at all, but a term or complex of terms. This may be seen by the fact that propositions in which such concepts occur are in general false concerning the concepts themselves. So remember, I went through it in the last video. A man. We can say, I met a man. And what I mean there is that I met an actual man. Whereas what it doesn't mean is I met the concept, the denoting concept, a man. That would be absurd, right? So if we take, wherever we see this a man, if we understand it as being about the denoting concepts, then pretty much any proposition that we form about it is going to be false. I met a man, or a man, if I write a man is a denoting concept, for example, Sorry, no. No. Yeah, forget about that. So, if I make a proposition about a man, any proposition that I make about a man is bound to be false. Okay, because a man is a denoting concept, and it points towards something. It automatically points towards something beyond itself, an actual person. Whereas if I do actually want to make a proposition about the denoting concept, a man, I can kind of put it in inverted commas, right? Or italicize it, or make it clear in some way. At the same time, it is possible to consider and make propositions about the concepts themselves, but these are not the natural propositions to make in employing the concepts. Any number is odd or even is a perfectly natural proposition, whereas any number is a variable conjunction is a proposition only to be made in a logical discussion. And notice in that second case, any number is a variable conjunction. The any number, I'll mark it on the screen, is italicized. In such cases, we say that the concept in question denotes. Again, we understand denoting as a primitive idea. We decided that denoting is a perfectly definite relation, the same in all 6 cases. So we understand that we're taking it as being that there is one way of denoting. Whether this is actually the truth or not, we've not fully ascertained, but for what it's worth, we may as well just take it that there's just a single way of denoting. And that it is the nature of the denoted object and the denoting concept which distinguishes the cases. We discussed at some length the nature and the differences of the denoted objects in the 5 cases in which these objects are combinations of terms. In a full discussion, it would be necessary also to discuss the denoting concepts. The actual meanings of these concepts, as opposed to the nature of the objects they denote, have not been discussed above. But I do not know that there would be anything further to say on this topic. Finally, we discussed the and showed that this notion is essential to what mathematics calls definition, as well as to the possibility of uniquely determining a term by means of concepts. The actual use of identity, though not its meaning, was also found to depend upon this way of denoting a single term. From this point, we can advance to the discussion of classes, thereby continuing the development of the topics connected with adjectives. So that brings us to the end of chapter 5. Again, I've not really decided exactly where I go from here, whether I just continue on as I was going to do with chapter 6, or whether I go back to chapter 1 and actually my aim would be to actually work all the way through part 1 of Principles of Mathematics, because to me part 1 is arguably the most difficult part of the book. It's quite intimidating actually in places, and it might take me a while to get through because there are certain chapters that I'm not fully comfortable with. One in particular, which I've mentioned a couple of times, is chapter 7, propositional functions, which I'm still very, very unsure about what he's getting at. So understand that these videos, by the way, they're not meant to be perfect in any way. A lot of the ideas that I'm expressing in these videos, I've never expressed to anybody openly before, because arguably there's nobody around for me to discuss these ideas with. I don't know a single person that is interested in Principles of Mathematics or knows anything about Principles of Mathematics. I'm sure that there are people out there. It's just that I'm not in any social circles where that's the case. So the ideas that I'm putting out are quite raw in these videos. What I might do at a much later date, once I've been through and made these videos, I may decide to produce a much more refined, polished kind of series of videos where I express these ideas in a much clearer, hopefully a much clearer way. For the time being, though, I'm just wanting to get my ideas out there. And if there is anybody out there that knows about principles of mathematics, that can see anything that I've misinterpreted or whatever, or that can put me on the right track with something, then, you know, that's one of the reasons, I guess, that I'm putting the videos out, so that other people can, not only can other people benefit from my ideas potentially, but also that I might be able to benefit from other people's ideas should they choose to share them with me. Okay, so I'll leave this video here then. It seems like a good place to stop. It's already been 1 hour and 20 minutes. We'll see what happens with the next video. It might be a few days before I can pick up again. I'm expecting that the next few days are going to be a little bit busy. But thank you for watching. If you would like to subscribe to my channel and hit the like button, please do so. And please don't forget to leave a nice comment in the comments section. And if you do have any ideas about anything that you'd like me to look at on my channel, please let me know. If there are any questions that you have about anything that I've said in these videos, I imagine that there's plenty of questions about anything that I've not explained particularly clearly. Then please, you know, feel free to ask any questions. Happy to help in any way that I can. But on that note, I'll leave it there. Thank you for watching, and I will look forward to seeing you in the next video.